In every forest on Earth, there is a creature 100 times smaller than a tiger or a bear, yet no less dangerous due to its cunning. This is the Ixodid tick. If a tiger attacks you, there's no way you won't notice it. But a tick bite is almost always undetectable, and that is its main danger. The longer it remains on its host's body, the higher the risk of transmitting viral infections it may carry, such as tularemia, Q fever, tick-borne encephalitis, or Lyme disease. In winter, ticks enter a kind of dormancy or hibernation and awaken in early April, even while snow still lingers in the forest. Frosts of 1–2 degrees Celsius, 33–35 degrees Fahrenheit, are not a problem for most Ixodid ticks. Their resilience raises many questions about nature itself. They can survive up to 2 months underwater, and up to 3 years without food. There are even records of individual ticks surviving without feeding for 10 or even 11 years. When severe cold arrives, they can fall into a cold-induced paralysis and thaw out once warmth returns. In addition, they are protected by a very tough chitin shell, like body armor, and cannot easily be crushed by fingers or even nails. Despite all this, they are equipped with highly advanced sensory systems that leave almost no chance for a potential victim to escape unnoticed. Ixodid ticks are temporary external parasites that feed on the blood of terrestrial vertebrates. They are widespread across the globe. No place on Earth can guarantee you won't encounter a tick. They are egg-laying creatures and undergo 3 developmental stages after hatching. To move from one stage to the next, they must successfully find a host and feed at least once. The first stage is the larval stage. The larva has 3 pairs of legs and a small number of barbs on its legs and proboscis. After hatching, it goes through a period of post-embryonic development. During this time, it is either sluggish or completely immobile. This phase lasts 7–10 days, after which the larva becomes capable of feeding and starts seeking a host. It has 1–2 months to find a host, after which it begins to weaken and may die. If it finds a host, it gains the energy needed to metamorphose into the second phase, the nymph stage. Although nymph in Greek means bride, in this case, a tick nymph is not a female, as one might assume. It's just one of the growth stages. The nymph is a young, not yet mature individual. The nymph grows an additional pair of legs and more barbs on its legs and proboscis, which are stronger than those of the larva. The nymph also needs to find a host to feed and transform into the final developmental stage, the imago. The imago is the adult tick, which seeks a host not to continue metamorphosing but solely for reproduction. For larvae and nymphs, the main hosts are small rodents, hedgehogs, and squirrels, while for adult ticks, it's large livestock, sheep, sometimes horses and dogs. Both nymphs and adults can attack humans. If a larva fails to find a host during the warm season but survives until winter, it does not enter full diapause, but rather a cold-induced stupor. As soon as temperatures rise, it resumes its search for a host. A larva cannot survive 2 winters without feeding. Most adult ticks, on the other hand, prefer to overwinter in a starved state. Adult tick activity begins in early April and peaks in May. During this time, Ixodid ticks are the most aggressive and actively seek hosts. In late May and early July, their numbers and activity sharply decline. The next peak comes in early September, coinciding with the ripening of rowan berries. However, even in September, their activity is still significantly lower than in spring. Ixodid ticks prefer shaded slopes and shrubs. In brightly lit areas, there are 5–6 times fewer of them. Coniferous forests are generally less infested than deciduous ones. Ticks are usually brought there by animals from neighboring habitats. An interesting fact mentioned in a 1970 source: ticks are fatally intolerant of lavender. Experiments showed that when placed in a test tube with freshly cut lavender leaves, they all died within 3-4 hours. The mortality rate was 100%. Almost the same results were obtained in test tubes with thyme, sage, and pyrethrum. They required about 12 hours, and the mortality rate was 60-90%. Adult ticks, imago stage, are active around the clock, but their numbers are lowest in the pre-dawn and early morning hours. One popular myth is that ticks drop onto people from trees, but this is not true. Ixodid ticks usually never climb higher than 1 meter, or about 3 feet. On average, the greatest number are found at a height of 25 to 50 centimeters, or 10 to 20 inches. Here is the general vertical distribution pattern of ticks in vegetation. Adults, imago, occupy the highest layer. Nymphs occupy the middle layer. Larvae mostly live in the forest floor litter. Besides Ixodid ticks, Arzamasov, soft ticks, and Gamacid mites can also pose threats to humans. Ixodid ticks are ambush predators. The key to their success is choosing the right spot to encounter a host, then waiting. Depending on their life stage and other factors, they choose a vegetation layer that gives them the best position for ambush. But in reality, this process is far more complex than it appears. As mentioned earlier, Ixodid ticks have highly sophisticated sensory systems that compensate for their poor or entirely absent eyesight. Some subspecies are completely eyeless. In burrows or caves, visual contact is useless for tracking a host, so instead, they rely on a range of other sensory organs. These include thermoreceptors, detect changes in air temperature, essentially working like a thermal camera. Mechanoreceptors, sense vibrations in the ground or substrate, helping detect the approach of a host. Chemoreceptors allow them to pick up on scent molecules. For example, these help ticks find animal trails in the forest by detecting sweat residues left by passing animals, then position themselves at the trail's edges. But the most important sensory organ is the Haller's organ, which detects carbon dioxide, CO2, a key component of vertebrate respiration. So even if you mask your scent, body heat, and move silently, the tick will still detect you by your breath. Tick attacks on a host occur in 2 phases: detection and orientation toward the host. Female ticks have been shown to detect humans from up to 15 meters, or 50 feet, away. Once oriented, the tick waits for the host to come within 8 to 5 meters, or 26 to 16 feet. Active waiting phase. During this phase, the tick lifts its front legs, which are rich in sensory receptors, off the surface and stretches them toward the host. This is when ticks are often seen posing with outstretched legs on a blade of grass, but they do this only during this specific waiting phase, when a host is nearby. The rest of the time, ticks stay in a passive pose with legs tucked in. If the host comes close but stops just short of contact, the tick may attempt active crawling to reach it. Whether it does depends on how hungry or aggressive it is. However, active attacks like this are not typical for most Ixodid ticks. Despite having finely tuned sensory systems and survival traits, ticks lack agility. Their horizontal movement range is very limited. An experiment illustrates this. Over 7 hungry male and female ticks were collected and marked with permanent paint. To recapture them, researchers used flagging, dragging a cloth-covered rectangular frame, called a flag or drag, through grass and shrubs, collecting any ticks that attached themselves. 500 marked females were released at a time into the forest litter. A month later, the area within a 50-meter radius of each release point was thoroughly checked. Results: 97% of the released ticks stayed within 5 meters of where they were released. 3% moved up to 10 meters. Only a few individuals were found 30, 50 meters away, though it's unclear whether they moved on their own or were passively transported by animals or birds. Ticks released 20 to 50 meters away from a frequently used trail began migrating toward it and spread evenly along the trail's edges. There are known cases where ticks that live exclusively in rodent burrows have also attacked humans. Burrow-dwelling species of ticks may crawl out toward the scent of a person if they are near the entrance to the burrow. This can happen, for example, if the primary host has left the burrow or gone into hibernation. In addition to poor agility, Ixodid ticks have another limiting factor: excessive caution when choosing a bite site. You see, encountering a host and successfully attaching to it is only half the task. The most critical stage is selecting the right place to bite. A tick almost never bites immediately. It usually crawls around the host's body for quite a long time, sometimes for several hours, searching for the ideal spot. On an instinctual level, it understands that this is a high-risk moment. If it chooses the wrong spot, the host may detect it. In the best case, it will be simply brushed off, in the worst, killed. Moreover, most animals have well-developed defensive responses against Ixodid ticks. Experiments were conducted releasing Ixodid ticks onto cattle, and the animals immediately showed signs of distress, trying to remove the parasite with tail flicks or by rubbing against hard surfaces. However, large animals turned out to be almost incapable of fully removing Ixodid ticks. Unlike other types of hosts, birds demonstrated a much greater capacity for self-cleaning. They managed to find and destroy up to 90% of the ticks using their beaks. The only relatively safe spot for ticks on birds is the upper part of the neck. Interestingly, many bird species are natural enemies of Ixodid ticks. Tits, finches, and other birds actively search for and consume them. The forest mouse proved to be the most effective at self-cleaning. It can remove ticks from its entire body, except for the neck. But even after a tick selects a spot and begins to bite, it may suddenly change its mind, retract its proboscis, and move to a neighboring area. If the new area satisfies it, the entire process of reattaching can take from 15 minutes to an hour. Feeding on the host can last from several hours to several days, depending on the tick's life stage. Once fully engorged, the tick detaches and immediately burrows into the litter, digesting the meal in preparation for molting or transformation into the next life stage. A fed tick may be attacked by another hungry tick, which begins to feed on its blood. Such cases of cannibalism are not rare. Usually, this is not fatal to the victim. No one can say for certain where the tick-borne encephalitis virus originally came from. Most likely, it originates in natural reservoirs. For example, deep in the forest, an animal becomes infected and passes the virus to a tick, which not only serves as a carrier, but also as a reservoir, transmitting it from generation to generation. It's been proven that almost all infections detected in a female tick were also present in her offspring, larvae, and the viruses remained viable. Although there are no direct microscopic observations of the virus's circulation inside the tick, studies show that once inside, the virus begins to reproduce actively. 40 days after infection, the virus concentration inside the tick increases by a factor of 10. There is also a conspiracy theory that the tick-borne encephalitis virus was artificially created in a lab as a biological weapon, and later either escaped or was deliberately released, eventually spreading nearly worldwide. Since Ixodid ticks feed on the blood of a wide range of animal species, They become infected with many different pathogens from their hosts and can pass them on to both offspring and new hosts. There have been multiple documented cases of ticks spontaneously carrying the plague bacterium, collected from natural plague reservoirs. Even today, there are occasional human cases of plague. One of the most recent cases occurred in Mongolia, when a person consumed an infected marmot. There is a 99% chance that the marmot was infected by an Ixodid or Arzamasov tick that already carried the plague microbe. The full list of infections that ticks can transmit is extremely long. But the most important thing to remember is, the faster you remove the tick, the lower the chance of infection. After a bite, it is necessary to visit a medical facility and submit the tick for testing to determine whether it was infected with encephalitis, Lyme disease, or other pathogens, and then receive appropriate treatment. On one hand, a tick carrying encephalitis won't necessarily transmit it to the host. On the other hand, there are known cases of Lyme disease being transmitted even without a bite, just from skin contact with the tick. So it's partly a matter of luck. Additionally, ticks carry many infections that don't affect humans, but pose a serious threat to animals. For example, they are vectors of anaplasma, which causes feverish illnesses in cattle. Thus, Ixodid ticks are essentially natural incubators and mobile biological labs, in which various viruses constantly evolve and multiply. Perhaps that is their true role in nature's design. They inhabit nearly every region of the planet and thrive in a wide variety of climates, giving them access to a vast diversity of pathogens with which they can interact. This video only briefly touches on the biology and behavior of Ixodid ticks. Many of their features and functions were not covered here, but the video provides a general overview of their nature.